Hi friends, good morning. This is Santosh. Today I am going to explain a very important concept that is microservices. What are microservices and what is the difference between microservices and monolithic architecture, and we can discuss about microservices architecture today. So microservices is an architecture style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, owned by small team. It means it have several features like loosely coupled means each microservices have own databases and own service, own UI, and so that is why it is a loosely coupled, and it is independently deployable. So each service is independent, so deploying also independently. Now we'll discuss about differences between microservices architecture and monolithic architecture. In monolithic architecture, it is built as a one layer system and is usually one code base. But in case of microservices, it is built as a small independent model based on business functionality. In monolithic architecture, it is not easy to scale based on demand. But in case of microservices architecture, we can scale. We can scale that based on demand. We can scale as a horizontal scaling and vertical scaling that we can discuss in separate topic. And it is a shared database. Normally, monolithic architecture uses a shared databases because for each application having uh, only one database, it is common for entire application. But in case of microservices architecture, having a model has their own databases. For each service have their own databases. And in case of monolithic architecture is a large code base. Normally it contains a huge data, that huge data and huge code within the application. So ID also, like if you are using any idea like IntelliJ or Eclipse or STS, so that tool will becomes very slow because heavy code it is loading. For that purposes, it is very slow, and build time also it will get increased in case of monolithic architecture. But in case of microservices architecture is independent and small in size, so overall build time and deployment time gets decreased here. And in case of monolithic architecture, it is a tightly in the sense because in only one application, all the database and the service, whatever the front end, back end, all the services that are tightly coupled in only one monolithic application. But in case of microservices architecture, it is loosely coupled because each module has their own databases and own service. These all differences between monolithic architecture and microservices architecture. Now we'll discuss about microservices architecture. So how it will look like here whenever here user is requesting any request, that will comes into the API gateway that will redirect what are the request will redirect to the appropriate microservices. So here there are two microservices, that are one is user microservices and department microservices that are registered in the service registry. So in the history dashboard, uh, sorry. So here we will discuss more about history dashboard, Jenkins server, config server, service registry, and API gateway. That all more in the coming slides. Now we are studying about service registry. Service registry is a database. Actually, it is a database used to keep track of the available instances. So normally it will tracking of the available instance of each microservices in an application, and service registry needs to be updated each time a new service comes online, and whenever a service is taken offline or becomes unavailable. So normally if you see in the diagram, service registry having service provider and service consumer. So it need to be updated each time a new service comes online. So it provides a mechanism for an instance to register. First, it will register in the service registry, and it will find out the service for that instance. Whenever the new service is going to register, new instance is going to register in the service registry. After that, for that instance, we will get the appropriate service for that instance. So that will discussed in the service registry. Now we will discuss about API gateway. API gateway, what is the importance of API gateway in the microservices and why it is required? Normally, when a client makes a request, we already saw in the previous architecture diagram that API gateway, from the user we are getting the request. So in that case, when a client makes a request, the request transfers to the API gateway and further it routes to the appropriate microservices. As I as I said, user requesting the request, and it will API gateway will route appropriate request to the particular microservices that I explained here in the microservices architecture. So now coming to the next point. Next point is the API gateway has responsibilities to provide the application client with API, perform request routing, provide authentication, load balancing, monitoring, composition, and protocol translation. That all responsibilities that will take care by the API gateway. And API gateway helps to provide additional security to your microservices. Whatever the services which we discussed, like two services, user and department services. So for that, it will provide additional security. API gateway helps to merge the communication protocols. API gateway helps to decrease the complexity of microservices, eventually improving the efficiency of the application. API gateway helps separate the microservices API and other external APIs to virtualize the design requirements and testing. That's all API gateway and its need. Now we moving into the history component. History is a library that controls the interaction between microservices to provide a latency and fault tolerance. For example, as the number of instances between microservices increases, the chances of failure of the microservices also increases in the system. In that case, we have to use a fallback method. It is called as a fault tolerance. Fault tolerance can be achieved with the help of circuit breaker. So circuit breaker, this is a new concept that we'll discuss in the coming. Historics, it helps stop cascading failures and allows you to fail fast and rapidly recover or fall back and gracefully degrade. So normally histories that we will use for fault tolerance, mainly, for example, number of microservices that are increasing. So we are based on the requirement or based on the demand, we are increasing the microservices. In that case, some of the microservices will fail and some of the microservices are not working. In that case, a fallback method is introduced to find out that fault tolerance. So that we'll discuss in the separate chapter. Now we discuss about config server. Config server is an externalized application configuration service. So normally it is based on the open source Spring Cloud config project, open source Spring Cloud config project, which provides a centralized server. It acts as a centralized server for delivering external configuration properties to an application like microservices here 1 2 3. So it is providing externalized information configuration in properties to an application. This, it is providing the properties to an application and a central source for managing this configuration across the deployment environment. So it acts as a central source for managing this configuration. It contains the configuration properties information. So that's all for of config server. Now we discuss about Zipkin. Zipkin is a very efficient tool for distributed tracing in the microservices ecosystem. Distributed tracing in general is a latency measurement of each component in a distributed transaction where multiple microservices are invoked to serve a single business use case. Distributed tracing is useful during debugging when lots of underlying systems are involved and the application becomes slow in any particular situation. Normally, distributed tracing is useful for debugging because lots of microservices are involved. In that case, we need to identify which microservices is slow and which microservices is fast, and we need to identify which is slow because we need to fix the issue why issue is occurring because of slowness. So that all for debugging purposes Zipkin is using. In such cases, we first need to identify which underlying service is actually slow. Once the slow service is identified, we can work to fix that issue. Distributed tracing helps in identifying that slow component in the ecosystem. That's all for the Zipkin. Yeah, this is all about microservices architecture. We discussed about API gateway and its need, service registry, why it came into picture, and config server, Zipkin server, why we are requiring in the microservices architecture. So thank you guys for watching this microservices architecture introduction. So uh, for upcoming videos, please subscribe and share, like the videos. Thank you guys. Thank you.